Hello guys, in this video I would like to explain about a machine learning algorithm which we called K-mean machine learning algorithm. This algorithm is used to make groups in the data, or you can say to make different cluster of observation and yeah, based on their similarities. So let's see um, how we can define and how we can explain this K-mean machine learning algorithm. Uh, what is K-mean? This can be used to cluster data sets to make different, um, groups of the data sets, and there will be example from the real world live from real world data, but that will be explained in the next video, not in this video. So this video is totally about the theory behind K-means algorithm. So what is K-mean? K-means is an unsupervised machine learning algorithm used for clustering data into groups based on their similarities. It minimizes the within cluster variance by iteratively assigning data points to the nearest cluster center that we call centroid, or you can say the mean value or the average value. So this is doing some iterative process and assigning the values to some cluster. Maybe it is assigned to one cluster, and in the next iteration it can be assigned to another cluster that have that will give you um, minimum variability in the cluster, in each cluster. But that is, of course, you should know that within a cluster. So we should this minimize the variance within a cluster. This means that this assigns the data point to the cluster which are closely related to each other, which are close to each other, and therefore the variance is minimum in that case. And let's see how this procedure works. Key concept in the k-mean clustering. So what are the main concept in k-means clustering? Clustering, the task of grouping similar data points together. So this simply that's mean the task is to cluster data into different groups. And K means each data point belongs to one and only one cluster. This is obvious that one data point should be associated with the single cluster or single group. Centroid, the central points of each cluster. So centroid means the average value, you can say. This is the central point of each cluster. Each centroid represents the average of all data points in that cluster. So that's obvious now. That's the average value of all data points in that cluster. Distance measure. So how we can measure the distance of centroid, the central value, and the values in of that cluster. Usually Euclidean distance is used to calculate how far each data point is far from the centroid. Maybe you can use other methods, but usually you can use this Euclidean distance to see which that the data point associated to the cluster, how far away are these data points from the centroid, from the central value. So these are some of the concepts which are used: clustering, centroid, and distance measures. How does the k-mean cluster algorithm works? This is important now, and of course you should know the concept before this. So we have done that. We defined the k-means algorithm, and then we talked about the key concept, and now we will talk about that how this work. The k-mean algorithm partitions the data into k cluster, where k is a predetermined number set by the user. The steps are as follow. So k is called the hyperparameter in this case. There are hyperparameter in the machine learning algorithm, usually in each algorithm, and you need to optimize that hyperparameter before you are going for prediction or something like this in your analysis, of course. So k is the hyperparameter in this case. And now how we can choose k, that's important. Now choose the number of cluster, that is k. K is the number of cluster. Decide on the number of cluster k for the data. This choice can affect the final cluster and is often based on prior knowledge or using method like the elbow method. So this is very important, and this is only one hyperparameter in the k-means algorithm. So this is important. You need to choose this wisely, and this you can use this based on your prior information, but there are some method exist, like one of them is elbow method, and I will have a separate video on this method, that how this method can work. So you can use available method to decide about the optimal number of k, which is the number of cluster in k-mean algorithm. Initialize centroid. Randomly select k data points from the dataset as initial centroid. So this means that if you have k cluster, you have decided about k cluster, then you need a centroid central value or average central value for each cluster. So that's mean, of course, you need to have k data, k centroid, one each for each cluster. So you can start randomly, but then this will be optimized, iteratively. So you can select this randomly in the initial. This centroid will be represent the center of each cluster. So in this centroid will represent the center of each cluster. Assign data points to the nearest centroid, and now so you have decided about the number of cluster, you have decided about the centroids for each cluster. Now you need to assign values to each cluster, and that's depend how much far away are those values from the from the center of each cluster. So you can assign a value which is nearest to the centroid of a cluster, and that way you assign all the values to each cluster. Assign data points to nearest data centroid. For each data point in the dataset, calculate the distance to each centroid. So you can calculate distance to each centroid, central value of each cluster, and then assign the data point to the cluster with the closest centroid. You can assign the value which have least distance to the centroid. You can assign value to that cluster. So these three steps you can repeat these steps. Okay, now the fourth step as well. Update the centroid. After assigning all data points, recalculate the centroid for each cluster by averaging the points within each cluster. The new centroid becomes the average position of all points in the cluster. So what is mean by this? Now, once you have decided about the number of cluster, you have decided about the centroid, you assigned values to each cluster. Now you have values in each cluster. You can update now centroid by calculating the average value of the data points which you assign to each cluster. Calculate centroid for each cluster now. So in the previous step, you have just assume or randomly select k data points as dataset as initial centroid. But in this step, now you can calculate, because you have assigned data to each cluster, you can calculate the centroid for each cluster. The new centroid will become the average position of all data points in the cluster. So now each cluster have new centroid which represent the average value which of the data points assigned to each cluster. And step 5, repeat step 3 to 4. Step 3 and 4 are repeated until convergence, meaning that the cluster assignments no longer change or the centroid stabilize within the predefined threshold. So you can use some criteria. If the distribution of the cluster are not changing, after a few steps, then you can stop it and you can say, okay, these are the final cluster or groups of the data point. Evaluate the cluster. You can evaluate the cluster, measure the quality of cluster using metrics such as inertia, sum of square distance between data points and their nearest centroid, or silhouette square, a measure of how similar each data point is to its own cluster compared to other cluster. So you can now evaluate the cluster as well by using some evaluation metrics like inertia and silhouette score, and maybe other as well. So this is all about the theory of the k-means algorithms, and we will have a separate video about the example, and then we will have separate video of implementing k-means algorithm in Python with the data and with OR in the data. So if you are interested, you can these will be available in a few days. So that will clearly define the k-means with the theory, example, and then implementation in R and Python. Okay, so I think this is enough for today, and see you in the next video. Ciao.